Okay. So we're opening up our note packet to section 8. And I have my factor sheet with me. Okay. So the biggest part of today is we're going to learn the last final type of factoring. So we have learned so far this unit how to factor with greatest common factor, how to do a basic trinomial, like what multiplies to this and adds to this, how to do two different special patterns, that's what section 7, how to do X box, and then this is the last one. It's called factoring by grouping. And this one's really easy to identify on your test because it's the only kind of factoring where you will see 4 terms. Now, it's called factoring by grouping because the classic way of factoring it is grouping it into like 2 different pairs. We're going to do it a little bit different, and actually I think it's a little bit easier. I'm going to show you a little bit of an easier way to do this. I kind of wish somebody would have shown me this when I was your age. So it's not really going to be grouping per se. It's more like factoring by a box. But this, if you guys in the X box method like can get to the point where everything's in the box and you're just finding what goes on the outside, that's kind of what we're going to be doing today. Okay, we're going to like jump straight to this step, and then we're going to figure out what multiplied to make all of it. And then after that, we're going to look at you guys, thank you so much. We're going to look at the back of your factor sheet, and we're going to look at this flow chart that's going on the back, and we're going to talk about how we get to use that for our test and kind of how that helps us decide which type of factoring problems we're looking at. So the actual factor by grouping is very straightforward. And we are not going to, our brains are on overload already in this unit. So like if there's anything I can cut out that you're not really going to see again, I'm willing to do that for you guys. So like that letter B, we're not going to worry about. Not that you can't do it. It's just we don't have to worry about ones with multiple variables. So let's not overload our brain with more than what we need. So the indicator that this is a factor by grouping problem is just simply the fact that there's 4 terms. Like that's the only time you're really going to see 4 terms when you're factoring. Also, you'll notice that there's an x cubed term. Usually that happens as well. So factor by grouping, the way I was taught, was to literally group it into 2 pairs and start factoring out greatest common factors, putting it all back together, blah, blah, blah. What is a little bit of an easier shortcut is actually just to use our little Punnett square box and place each of those terms in one of the squares. I don't believe the order really matters. I would have to check like every single order, but I usually just go right in order. So I usually go, okay, x cubed is going to go in the first box, 3x squared in the second box, 2x in the third box, 6 in the fourth box. Like I just go in order. So I don't even make it a big deal. But you put each term in a square. And then just like in the X box method, once you have it all laid out in the square, your goal, the puzzle to solve, is what multiplied to make all of that. So just like in X box, at some point you're going to have to do a common factor, a greatest common factor. So I usually just look at my options, like look at the first row, the second row, the left column, the right column, and figure out where is there going to be an easy common factor to pull out. So like this jumps out at me first. Who can raise their hand and tell us the greatest common factor of 2x and 6? Caitlin? 2. So that's going to go right on the outside of that row. And then from here again, this is all like a multiplication game, which I actually feel like even my students who are coming in for help and not really understanding this stuff, I feel like we don't do okay with this part. Once you have that first term, just start plugging it into the multiplication game here. So like this box of 6, 2 times what equals 6? 3. So we're going to put a 3 here. Let's do this one next. 2 times what would equal 2x? A 1x, yep, or an x. Okay, we haven't really seen this yet. It's not impossible. This one here, it has to multiply to make x cubed with the x, and it has to multiply to make 3x squared with the 3. Brayden? X to the second. Very good. Yeah, so that's going to multiply to make 3x squared, and x squared times x would multiply to make x cubed, and those are your factors. It doesn't really matter which one goes first. I, just being a mathematician person, usually know that the higher exponents typically go first, but it doesn't matter. So I keep getting that question over and over. You guys, the order of the factors will never matter. Like, you can have it like this too. Both are correct. What questions do you have over that? Okay, so it's a little bit different than Xbox because you have 4 terms instead of 3 terms because the middle ones don't combine, but the actual process of finding what multiplied to make it is actually the same. Okay, we're going to skip the one with multiple letters. We're good. We don't need to cover it. And we're going to go down here. Not worry about this one, but we can go ahead and tackle this one. So again, I just typically will go in order. Okay. So it doesn't really matter again where you start. This column kind of jumps out at me. I definitely know the greatest common factor between 3a squared and 3. What can you pull out of both? 3. Not 3a, because that doesn't have an a, so you can't take an a out, but you can take a 3 out. Okay, maybe I'll do this one first. This is always the easiest one. 3 times what is 3? Okay, maybe this one. And next, 1 times a would be a. And a to the second power. Exactly. You guys got it. And then I always just double check, just to make sure. Order doesn't matter. That's factor by grouping. That part's pretty easy, right? Like, I mean, first I was like, oh, not that, like their homework was a piece of cake. Now, what I want to do, because we have some time today, that's the last type of factoring, is I want to talk about how we're going to use this factor flowchart. So, on the back of your factor sheet, is a flowchart that I'm going to add a bunch of notes to. So if you have like colored pens and highlighters and anything that would help you kind of follow along with me that might be helpful to get out. I do have some highlighters over in a box over there if you want to grab out a highlighter. I don't know if I have any colored pens left over. I might have some blue pens. I'm not really entirely sure. Zoe's got the hookup. You and Mallory might have the same, or is it Mallory or Malaya? Mallory. Yep. Now, let me clarify something. So Taylor said, so we are allowed to use this on the test. Yes. That doesn't mean, though, that you can add whatever notes you want on it. Like, it's not an open note card for you to just, like, write whatever down. No. But I am going to write quite a few examples on here, so just make sure you're writing down what I write down as well. Now, the first thing, whenever you're factoring, so there's going to be a whole day of the factoring part of the test will be next Thursday. We're going to do that first and do the easy part Friday, just because then Friday is like a, whew, I just have to show up and take the easy part. The first thing you have to do is start with this question. Is there a common factor I can take out? Now, That could be a number. It could be a letter. It could be a number and a letter. It could be an x squared. There's a lot of options, but if there's anything you can do to simplify the problem and take something out of all of it, you need to do that, okay? So if there's a common factor, then you're going to factor that GCF out. That's the first type of factoring we ever learned was GCF, and then they give you an example of that. Okay. Anytime you factor out a GCF, you should take what's left over and see if you can keep going. Like, see if you can keep breaking it apart. Now, this specific one, there's nothing else we could have done with the x plus 3. Like, it's a factor, it's done. But if it was something like x squared plus 4x plus 3, then you'd be able to keep going. So that's just what this message means right here. If you are done with your GCF, see what's left in parentheses and see if you can keep going. Now, if there is no greatest common factor that you can take out, now we go down this column right here. And you'll notice right down this column there are 3 questions. Are there 2 terms? Are there 3 terms? Or are there 4 terms? If there are 2 terms, so you look at your problem and it's like x squared minus 16. 2 terms. First thing you should ask is if it's a difference of 2 squares or a difference of perfect squares. So this was one of those special patterns. This was a special pattern. So a difference of 2 squares might look something like this. 16x squared minus 9. It could look something like that. That would be a difference of 2 perfect squares. It's a difference, there's only 2 of them, and they're both perfect squares. The way we get to our answer, just to remind ourselves how we get to this, is we just simply square root both terms. I didn't really leave myself a lot of room here, that's okay. The square root of 16x squared is 4x. The square root of 9 is 3. One factors plus, one factors minus, and that is your answer. I did not space that out very well at all, and I apologize. Okay, so it's possible that if there's only 2 terms and you're like, yep, there's only 2 terms, that it's that special pattern. Well, that's the only one that only has 2 terms, that special pattern, unless it's just GCF. Okay. If there's not 2 terms, and there's maybe 3 terms, so like x squared plus 4x plus 3. If there's 3 terms, you want to ask first, is the leading coefficient 1? So that would mean something like this. Okay? That would mean like there's nothing in front of the x squared. Now, it says if the leading coefficient's 1, you do the x method. I never did this with you. We never did x method for just a basic trinomial. I called this a basic trinomial because if your coefficient is just 1, then you're just simply asking what multiplies to this and adds to that. And then you would fill the numbers in. So if you have 3 terms and your leading coefficient is 1, that is a basic trinomial. I never did X method. I just we didn't need to complicate it. What multiplies to 3 and adds to 4, those are your factors, and you move on. Okay, I will leave this on the board the day of the test, as long as my custodian doesn't erase it. So if that helps you with the negatives and positives and all that. But remember, you can always double check your factors, like literally multiply it and add it and see if it makes those numbers. Okay, but what happens if the leading coefficient is not 1? So like what happens if there's a number in front of the x squared? Okay, now we have 2 options. The first option is that it is a perfect square trinomial. So this was a basic trinomial. If the leading coefficient is not 1, it could be a perfect square trinomial. So that would mean that your first and your last terms are perfect squares. So something like this. So you would notice that your first and your last terms are perfect squares. So this is another special pattern. Okay, and how we get to our answer is you square root the first term. Square root of 9x squared is 3x. And you square root the last term. Square root of 4 is 2. Whatever the middle symbol is the middle symbol that you drop down. And it's that factor squared. And that's your answer. Okay. If it's not a perfect square and a perfect square, so like any number that's not a perfect square, so if this was like a 26 or something that's not a perfect square, that's when you're probably going to have to use the Xbox method. Now here's all I'm going to really add to the Xbox. I'm not going to put an example here. But what I'm going to add is just whatever your trinomial happens to be. The A times C is what gets multiplied to make this top part. That's always the number you're multiplying to. And it's really kind of still like here, what multiplies to 3 and adds to 4. It's still kind of like that. It's just you have to also multiply it by the number in front. The B is the middle number, and that's what it adds to. And then remember, the M and the N are what go here and here. And you fill in your box from there. The worksheet you just got back, a bunch of you missed something because you didn't actually write the factors. So remember, your answer still has to be written like this. Like it has to be written out as factors. You can't just fill in the box and move on. So that was the 5 we already knew. GCF, difference of perfect squares, basic trinomial, perfect square trinomial, Xbox method. The last one we learned today would be like when you go through that first question, how many terms are there, and you see 4, you go straight to the bottom. That one is the factor by grouping. We don't really group it. We're actually using the box. So if you are curious about how factor by grouping works, this is how it works. But we just used the box instead. So I'm going to take that same example and put it all in the box and show how you can get the same answer. So I'm just like taking what they have right here, putting it in the box, and I'm going to factor it all out to get my two same factors that are at the bottom. So I can take a 3 out here, I can take a 6 out here, I can take an x squared out here and an x here, and that's where my two factors come from in either order. So what we're really going to work on next week is like practice going, like using this flowchart and figuring out what kind of factoring we're looking at and how, and because I think you can actually do the factoring, you just have to know when to use each type, right? So to kind of ease us into that a little bit, we're going to do a few problems, just 2 more problems off of the note packet, and then we'll get to our homework. So don't lose this. That would be unfortunate if you don't have this the day of your test. People already lost their note cards because I have them over here. So that'll also be unfortunate if you lost all the naming note cards. Don't worry, we'll go back and review that stuff too, how to do all that. Okay. May I continue? So I would like all of us to take a look at, and I'm going to have my flowchart right next to me so I can use it as a reference. I'd like all of us to look at the top of that next page. We're just going to do 2 problems, and then we're going to call it good, and you're going to work on homework. The homework will not take you very long. So please try not to work on homework right this second. Like, I don't usually care, but I do want your focus and attention on this right here with me. So we're going to call this factoring completely, which means just like break it down as far as you possibly can until you reach a blockade, like until you reach a dead end. Sorry, I was like, what is the word I'm looking for? Dead end. So we had just finished the factor by grouping. It's the very next page at the top. All right, my factor flowchart. The first question you have to say, is there a common factor? Is there something you can divide out of all of this? Now, it can't just be, is there a common factor? It has to be, what's the greatest common factor you can take out of all this? So before you say anything, there's 2 parts to the greatest common factor here, because I see a number I can take out, but I also see something else I can take out of all 3 of these. Okay, now I'm ready for it. Braden?
Oh, you can take 3 and then
Good. You can take a 3 and an x out, because all of them have x. That doesn't always happen, but this one it does. So I divide each of these by 3x. Now, some of you on your concept check yesterday, you just let that drift off the page. You can't do that. So whatever your greatest common factor is, it just has to go to the front of your problem. It can't just like drift off the page though. Okay, we have to be able to divide a little bit here. So, Annie, what's 3 divided by 3? 1. And what's x cubed divided by an x? What's left? Good. Okay. Keegan, what is 6 divided by 3? And then Keegan, x squared, and we divide an x away. What's left? Good. And then our last one, not here, our last one, Amelia, negative 18 divided by 3. And what happens with the x's, Amelia? They cancel out, exactly. Okay. Then our flowchart says, with what is left in the parentheses, follow your flowchart. So now we're just looking at the parentheses. We go down the line. Are there 2 terms? No. Are there 3 terms? Okay. The next question then, is the leading coefficient 1? In the parentheses? Mm-hmm. So this could potentially be a basic trinomial. Are there any 2 numbers that multiply to negative 6 and add to 2? So here are my factors of 6. I don't think I can make 2 out of that, right? So that's where you stop. If you could keep going, you would keep going, but that one you can't. That one you just stop. It's not prime because you were able to do something, so it's not a prime problem. You just can't keep going. Okay, our next one. Start with your greatest common factor. I see a greatest common factor. I can factor out of both of these. Taylor Perrick. I agree. You can take out a full 7x squared. If you say 7, that's good. That's part of it, but that's not the whole thing. You could take an x squared out as well. Okay? So what's left over, Braden, what's 7 divided by 7? 1. And what's x to the 4th divided by x squared?
X to the second.
Good. Okay? The minus sign drops down. Olivia, what's 28 divided by 7? X squared divided by x squared. Liv? X squared divided by x squared. Okay. With what is left in parentheses, follow the flow chart. Are there 2 terms? Yes. Is it a difference of 2 perfect squares? Sure is. It sure is. Both of those are perfect squares. What's the square root of x squared? What is the square root of 4? -2. And in this pattern, 1's always plus, 1 is always minus. Now you're done.
If it's negative, let's say it was negative 4, would it be negative 2? Or,
You can't square root negative numbers. Yeah, it'll give you an error message. You guys will learn about something later where you deal with that. Okay, now your homework is just the factor by grouping. So this is just practice for next week. You guys, sorry, every time you talk, I have to get louder and it hurts my voice. And I'm getting paid to sing tonight, so I really need to actually not be yelling. I know. So you guys have a homework assignment. Yeah, the bronchitis really set me back too. So your factor by grouping is not going to take you very long. You don't need to worry about 2 or 3 because they have multiple letters.
What happens if I did 2?
That's fine. They're not impossible. It's all letters and no numbers. Well, actually, 3 has numbers, but.
Are we allowed to rearrange the order instead of setting up?
You should be able to. I don't think it ever matters, so you should be able to. Okay, you guys need to work on 1 through 8, please. That's 6 problems. I don't think it's going to take you very long, and you have 11 minutes. So when you're finished with that, you can check it at the front, and then you can please just sit quietly and do something or do missing work. Some of us still have missing work, and it's due in a week. So that'd be a good thing to get done. You're doing the whole thing except 2 and 3.